Hi everyone, my name is Pen and you're welcome to my C programming language tutorial. Today we are going to dive into writing socket programming in C. Okay, what this socket program is going to be about is going to be a program that has to do with server and client. Okay, I basically most times talk about server and client, which telling you guys to learn socket programming. But thinking about it, what is this socket programming? Socket programming is simply a way in which different processes communicate together. Okay, you can see it as a application in which you write. It can be a server, it can be a web server, it can be an application that uses a network. That network simply means multiple processes or multiple computer, different places in the world connecting to your own computer to communicate with your computer, whereby they can send messages to each other. Okay, so that is basically what socket or network programming is all about. Okay, so we are going to do basic thing related that is related to socket programming. Okay, it's gonna be very basic because I want in a situation whereby what I'm doing you guys will have understanding and be able to follow in the code I'm going to write today. So speaking about what I'll be doing today is it's gonna be a chat application. Okay, a chat application whereby we can communicate. Two different programs can communicate with each other by sending messages. The client can send to the server, hi, how you doing, server? Then server can reply back to the client, oh, I'm fine, how you doing, to client? Then the client can reply, oh, I'm great, in fact I had a wonderful Christmas holiday. They communicate with one another just the way we have the WhatsApp application. Okay, there is a group in WhatsApp whereby thousands, hundreds, tons of people can join into that group and communicate simultaneously. How does this thing works? Now this is how it works. The server itself is the WhatsApp application. Okay, so the WhatsApp application is a computer that sits somewhere, any place in the world. Okay, where that computer is locally installed. So the server creates client or allows clients to connect to them. Okay, so those clients connecting to that WhatsApp server is you and I that are logging in or creating account in WhatsApp. Okay, someone downloads WhatsApp in his laptop or smartphone and create an account using his phone number, create an account for himself. That person is like a client connecting to the WhatsApp server. Okay, so if that person is in a group whereby there are tons or thousands of people, okay, there is Mr. John, there is Mr. Philip, there is Mr. Peter, there is Mr. Andrew, there is so many people there. These people are communicating. Everybody in that group are clients. Okay, so when Mr. John, for example, want to send message to Mr. Philip, what happened here is that Mr. John send hi to Philip. It does not go direct to Philip's. He first land on the server, which is the WhatsApp itself. Then the WhatsApp is built to understand and relate with its client. So it takes that message and understand that, oh, this message Mr. John is sending, he really want to send it to Mr. Philip. And the server, which is the WhatsApp itself, package that message and send it to Philip. And once it reaches the end of Philip unpack it and look at the message and say, oh, that Mr. John sent me hi. Then Philip can reply back, oh, what's up, how are you doing, how is your day going? Philip will now send that message back. It will not go straight to Mr. John. It will just go to the server, which is the WhatsApp, and the WhatsApp will package it, understand that, oh, Philip is sending this message as a reply message back to Mr. John, and the WhatsApp server will package that message and send it back to Mr. John. So this is how they communicate. So if there are hundreds of people there, this is how processes works. This is how each person communicate with one another. But these things are done in speed of light though. But you don't know because they're done behind the scene. Okay, network programming is something that one need to learn because most of the software out now need networks. Look at the TikTok application, look at the Facebook application, look at servers, look at Linode, Amazon, look at DigitalOcean, PortMap.io, those kind of beautiful websites that can do stuff. Okay, so I want you guys to go into socket programming. Despite the language you are using, it doesn't mean hence you're not doing HTML and CSS. If you are doing JavaScript, make sure you are working with network, doing socket programming. If you are learning PHP, make sure you are doing socket programming. If you are learning Java, make sure you are doing socket programming. Okay, if you're learning C++, make sure you are doing socket programming. If you are doing low level language like assembly, make sure you are doing socket programming. If you are doing C just like mine, make sure you are doing socket programming. And lastly, anyone can follow up with this video why I'm coding, because I'll be doing everything live. Okay, so if you are in Linux, good luck, you have the right system, operating system installed in your system. If you are in Windows, you can install Virtual Machine or VirtualBox or VMware, anyone, and install any Linux distro. You can install Ubuntu into it, or Kali, Mint, Manjaro, Parrot, or even Arch Linux. Any distro of your choice, you can install it into a VirtualBox. Okay, or Windows 10 and 11 have what we call WXL2, which is called subsystem for Linux. There you can install Ubuntu, Kali, Fedora, Arch Linux, any distro of your choice inside the WXL. Maybe I will do video on that, but there are so tons of videos on YouTube you can watch to run WXL in your Windows, so that I can be able to code, because everything I'm going to be doing is going to be low level. I'm going to be making use of the assembly system call and the C standard libraries. Okay, so this is going to be a powerful program, so you guys see how things actually works. All right, enough of the explanation. Let's dive straight into the real deal. Okay, so I'll press my Ctrl L to clear the screen, then I'll press Ctrl U to remove all this welcome to Pencil programming language tutorial text. So I'll press Ctrl U and that will be wiped out. Okay, and that is it. I'll make a directory for myself. Okay, I'll call this socket, call it sock programming. Okay, oh yeah, that is a very nice name for this program, for this directory, sorry. So I'll just do the cd to sock programming, and then I'm inside the sock programming. Ctrl L to clear my screen. Now I want to explain something here before we proceed. And again, guys, I don't know how long this video will take, but it's not gonna take much. But I'll make sure I explain, and as well, once I'm typing, I'll be typing fast as well. Okay, there are gonna be errors though, but we'll fix all that. Okay, because while I'm coding, I normally make typing errors. Those kind of errors is something that we all do though while typing. All right, I want to introduce you guys to a CLI application called TMOS. Okay, what TMOS basically do is that it allow us to create multiple sections. Those sections are multiple terminals. Okay, now since we are writing a server and client application, which is a network program, okay, we would like our client and our server to communicate. And since I'm using one device, I can't communicate. So what I'll be doing, I'll create two terminals using the TMOS, and I'll split those terminals into multiple sections, into two sections. Then I will execute the client in one of the terminal, and I will execute the server in one of the terminal, and allow the two applications to communicate with each other. But a basic intro on how TMOS works. If you just type your TMOS, just as I do, let me just clear it. You type TMOS. If you don't have TMOS installed, if you are using Linux distro or WXL Ubuntu, you can type sudo apt-get install TMOS. Okay, so that is just the simple installation, how to install it. You press your enter key, and I already have it, so I won't be installing it. So I just clear the stream. If you are using your Android phone, you are using the TMOS app, which you download from F-Droid or Play Store. To install it, you type apt in your Android phone. This one is for your Android phone, guys. So apt install TMOS. Okay, so if you just type it like this, you don't need to put sudo. Just type the apt install TMOS, or you can use this method, the apg install TMOS in your smartphone as well. Okay, so for those of that are using smartphone as well, you can follow up. So that is it. So let us see how TMOS works. We type TMOS and we press enter. You see the terminal change. If you look at the bottom, we have localhost, bash, column, all this kind of beautiful, and the terminal now looks more bright. Okay, so how can we split the screen into vertical and horizontal form? They are keyboard stroke. You hold your control key and press your B. Now you are into a mode called escape mode. In that escape mode, now whatever you do, like holding two combination key like shift %, gives you a vertical form. It is vertical or horizontal. can't remember, but you guys should just know. All right, so if I do ls now, you see I'm in the right terminal section. If I do tty, you will see that this is a terminal 2, which is /dev/tps/2, means this is a separate terminal. I can move to the left terminal by pressing Ctrl B and just press only semicolon. I'm in the second terminal. I can do ls here. You see, I have 2 terminals running. I can type tty, tty, and press enter. See, this one is terminal section 1. Even inside this left terminal, I can also split it into horizontal by doing Ctrl B, Shift, quote. You can see now I have 3 terminal now. Okay, I can move to the left, to the right, sorry, and also split that one into horizontal mode. So I press Ctrl B, I press my arrow key, which is the arrow key in the keyboard. Now I just move to the right hand side, press my Ctrl B and Shift, quote. You see, I split. I can also split this one, which I just I'm just into, which is tty, to see the section of this one, which is terminal 4. I can do Ctrl B and Shift %. I split it again. So you see, I have multiple section here. Okay, I can go to the top left up and also split that one. If I do Ctrl B, Shift, Ctrl B, arrow key left, Ctrl B, up, Ctrl B, arrow key. Okay, I can now do Ctrl B and semicolon, Ctrl B, up, and Ctrl B, side, Ctrl B, up. Now see, I'm in the up one. Now ls, I can also split that, Ctrl B and Shift %. I split that one too. So you see, I can split the screen to multiple section I want. If I type tty to know the terminal section of this one, you see, is terminal 6. And if you count of a truth, 1, 2, 3, 4, 5, 6 is 6 terminal we have. So you see, with the TMOS, you can split your screen to multiple section. Okay, so enough of TMOS explanation. How to exit out of all this terminal? You just type your exit in each one of them. You just keep typing your exit in each one of them. Okay, exit in each one of them. Okay, now we have 3 exits. Now we have 2 exits. Now we have 1. Now I can say exit to come out of the TMOS mode. Now I'm back to my normal terminal section. Okay, so that is it about TMOS. Okay, let's write now our code. So for us to write our code, we need to create 2 files. One will be called the server.c and the client.c, and that is created. If I do ls, you see that has been created. So we start by writing our server first, because that is the brain, actual brain doing the real work. So vim, so I'm now into the vim editor. Press I for insertion key. Then I will be commenting every code here so that you guys will understand what I'm doing. So this first header file will be the C standard libraries. Okay, so I will start including the standard libraries. Okay, I will include the stdio.h. okay, I will also include the stdlib.h. I also include the error number.h. I'll also include the unistd.h, because I'll be using the close system. Yeah, the close. The unistd.h is not a standard library. No, it's a standard library. Yeah. So those are pretty for C standard library. So I'll do my /asterisk. This will be called the assembly 6 them course. Okay, so now we do the include we're going to include the sys /socket which allows us to create socket.h. We also include, let me move this thing so that you guys could be seeing what I'm doing. Okay, I'll move this camera on also. Okay, oh sorry, I'll move this one. I'll also move this one here. Okay, those things are disturbing, so you guys can be seeing the screen very well. So I will say upper /inet.h, close. All right, hash include net inet /in.h. all right, yeah, I think these are pretty all we need for now. So I'll be defining some macros. Okay, a macro called true, and true will be 1. I also define protocol. Okay, let me give this another tab to make it look nice. Protocol should be 0, no semicolon. Then hash defined buff underscore size, and this should be let's say 10,000. Yeah, so I just want to create a big size for memory, because I'll be using array here, so to allocate a static memory whereby the read and write data will be stored inside that memory. Okay, so now I can start writing my main. I will accept arguments from the command line, so I'll pass arguments into the main function. So argument count, argument sharp, pointer of vector of array, open, return 0 if everything works fine. All right, so now we can start writing our code. So I'm going to create 2 file description. One should be called the server underscore fd file description, comma, client underscore fd file description, comma, then port. And secondly, I'm going to create a character of pointer called ip, comma, I'm going to create a buffer of array. We pass it the buffer underscore size. Okay, and we close this array, semicolon. Yeah, so the next thing here, I'm gonna use the struct sock address underscore in, and I will create a server underscore addr, which is address, comma, and I also create a client underscore addr server. Press my enter key. I'll just make this text a little bit smaller. Okay, so I just made it a little bit smaller so I can fit the screen. So the next thing is I'm going to get the size of this client. We are going to need that, so press enter. I'll say sock length underscore t. This is already declared for us inside the header file of this sock function. Okay, I'll also use, I just remember also I need to include the file control.h so that I can make use of the close function. File control. Okay, socket length, I'll call this client underscore length. I'll say equals to get the size of the client underscore addr, and we close, and that is it. So since we are done this with this, so the next thing is to check for arguments we are getting from our terminal. So we say argument if greater than 4, our argument should be 3, but if it's greater than 4, that means we encounter error. Then we use the print error, which is the p error. We say the p error function, okay, which is inside the stdio. So what are we printing? We say 2 oh sorry, too many arguments pass, and that is it. I'll press enter and we return, because we encounter error, we return 1, because our main here returns, remember our main here uses int, which is this int, so it returns something. So anytime we need to return 1 or -1, but we'll be returning 1 because 1 means domain error. So we close this. So but if everything here is okay, this condition is satisfied, then this error will be skipped. Then our code continues below here. So below here, since everything works fine, we set up our IP gotten from argument of vector of array 1, okay, and semicolon, and we pass to our port equals to the character to integer function, and we pass in the argument of vector of array 2, and we close this function. So what this basically does is that it converts the string to integer. Remember, if you are getting argument from the terminal, it's seen as a character. I will show you. So when we pass argument, remember here, this argument of vector here is a character of function of pointer of array. So when we are receiving from the second here, which is the third one to be precise, the second is the third one actually. So when we are getting an array. So what this function will do here now, which is this character to array, it will say convert this character to an integer. And remember, this port here is an integer, so the integer return value will be stored in the port, which is we declared at the top here. You can see it here at the top here. We declare the int port. Okay, all right. So we continue. I put my semicolon and we continue. Okay, the next thing now is to I will say let's create create socket. Okay, so I will use the if statement, open bracket, another open bracket. Okay, so we say client, sorry, not client, remember this is server, so we say server underscore fd, which is the file descriptor, is equals to socket. Okay, socket takes in the HAF underscore inet family. Why? Because we are doing TCP connection, not UDP. UDP is version 6, while TCP is version 4. So the difference between version 6 and version 4 is that TCP connects as a strong connection. When it's connected, it can send data through that route is connected to, but UDP does not have a specific connection. It's just like multiple things are connected to one source, and different ways files are being sent in. We normally use UDP when you are writing games, okay, because most times you have so many enemies, and those your guns you shoot is like a pointer pointing to those enemies. So we normally use UDP port on that, but when we are writing programs like this, we use TCP. But you can use UDP if you know your way around and how to do that. So to say we are using the TCP connection, which is what we are supposed to use, so TCP underscore steam tell us that we are using the TCP. Now we pass in our protocol, which is we defined as a micro. Remember, we define it as a micro here. You can see it, which is 0. If we didn't define it as a micro here, so the spelling was protocol, yeah. So if you didn't define it as a micro there, we'll just pass 0 here. But because we define it, so we just pass in the actual name. So I'll reduce this a little bit. Then, since we have reached the end, then we close and we say if this is equals to -1. The I'll make it smaller again. Say this function on error, which is a socket, returns -1. So if there is -1, so that means we encounter error. I'll be using the fprintf. I would have used the error function like this, okay, and pass in the either 1 for write or 0 for read. But I won't be using the error because I didn't include the error.h. I want to use error number so that you guys can also understand how error numbers works. And I also do a separate video on error numbers. There are 133 error numbers in C system calls. It's used in general Unix and Linux operating systems. So anytime you are generating error, you see any error like 404, this kind of error, they are generated from the system call, which is the error number. Okay, so I'll use the file printf which is a standard stdio function. We are referencing to use this on fprintf function. So we say fprintf function, we pass in the stdr. So in this std we have std out, std in, and std error. So std error is to the screen also, but in a different dimension. We are telling the system that we are not sending as a proper write out to the screen, no, but we are sending as an error. So this is indicated as an error in the system. So we say we like to be specific here, to be direct. So we say the socket error number. So I'll pass in %d. Okay, I would like to give arrow sign because I would like to get the actual number of this error, what it actually means. So I'll pass %x backslash backslash n, which is new line, and I put my double quote. Then here I'll pass in my error number, which will be printed as with the %d format. Then after that I will use a function called string error. Make this little more smaller. String error, and I'll pass into string error the error number. Make this a little bit more smaller. Okay, error number, and I close this, and I close the last one. I put my semicolon, press enter. Since we encounter this error, we return 1. Okay, before we return, we are supposed to close this file description using the close, or say we are closing the client, the server underscore fd, because we encounter error. If we do not close it here, so the memory will still this file descriptor is still in use, but why is not in use? So that is what we call memory mismanagement. But for us to manage our memory properly, we have to close it. So I will just say I'll comment it here, close server fd. So simple. So we return 1 here, and at the end we close this. Then I will use the else statement, open curly brace. Then if everything works fine, then if this condition we do here equals to -1 is not true, which means we do not encounter any error, that means this code here, this code inside these braces, fprint, close, and return, will be skipped. Then we'll just enter into the else, and the else now is where we'll now set up the server underscore eddr. This has to do with, I will just comment it, is called set socket address. Okay, so we are setting socket address. Remember, when you buy a wall socket in your house, you have bought the socket, the next thing is to mount it. When you mount it, you begin to connect the wire to your actual power supply in your house. So that is what this address is really doing. So we say socket address dot scene. Now we are visiting the structure of sock address underscore in to gain access to its family struct, which we give the family of ef underscore inet. That is a TCP. Then we also do server underscore ddr dot scene. Then we pass in port. It's supposed to be underscore port, because we are getting the port this time is equals to h2 network socket. Then we pass in the port, actual port. Then the next thing is a function called inet underscore port to network. Okay, this function is accessed to by this net inet header files. Okay, so we use it. So what the function does is that, first of all, it collects the network family, and a character of pointer, we have already created that as an IP we are getting from the argument, which is this IP here. Okay, and remember that this IP here, remember we give it the argument of 1, which is the IP we are passing in. The reason why I'm doing it like this, because you guys may want to use your own IP of your computer, okay, or you can also use the local IP, which is 127.0.0.1, or use any IP which your computer is or laptop or phone is using. Okay, so I will just pass in the IP. You do that as well. So you pass in the IP, comma, and the address of the server underscore addr dot syn underscore addr, which get to that sock structure and semicolon, and we are done with this. Okay, we are done with the socket creation and setting up socket address. The next thing is we need to bind the socket now. So I will say bind socket. Okay, bind socket. Now bind socket has to do with now the connection with the socket to your house, like your wallet, the real power supply in your house. I'm just using that as a illustration, guys. So I will use the if statement again because we'll be getting error here. I will say bind, say bind, we need to pass in the server underscore file description, comma, then we'll pass in the struct of sock addr pointer. Now we are casting it, we are like saying, okay, instead of struct pointer, we are casting it with this address. Okay, like we are casting with this address, saying we actually want to use this address we created using the struct up here, using the struct up here. If you remember, using it this struct, remember, using this address. So we say we are casting it to that address. So we are saying server underscore addr, simple as that. I'll put comma, and we get the size of, that is just how band work. You need to pass in the size of, you get the size of what, the server underscore addr, and that is it. And lastly, what we do next is we check for if this is less than 0. Okay, then we make this smaller again, then open curly brace and enter. So inside here now we can do if, sorry, not if, we can use if to check for errors, but I will just for simplicity use printf. I don't want the code to be more complicated, so we send this to, as usual, standard error, and we'll pass in our string. What are we? Say binding error number, remember that. So we pass in %d arrow and %x. Okay, I'll pass in \n, and we pass in our error number, comma, and the string error, open bracket. Okay, string error, open bracket, and we pass in the error number, and we close semicolon. Okay, if we encounter this error, then as well we close the file descriptor too. So we close the server underscore fd, remember that, semicolon. So I'll comment it, I always comment this particular one, say close server underscore fd. Okay, so that is, after that then we return 1 as the error to our main, and we close. Okay, so that is it for the band. Band is now set up. If everything inside this if statement condition testing is satisfied, then this code here, this printf and this close and return 1 will be ignored, and the code will not jump to the next line. Okay, so binding, works fine, that means we're in the next line. The next line is we use the if state again to listen. Okay, now we are listening. The function called listen. I will just give it a comment. Okay, say listening for connection. Okay, so we are listening for connection. Now listening for connection simply is like, oh, is there light or is electricity coming in? Like, is there power supply actually coming into this our power bank or something like that? So we use the if. We say if listening, we pass in the server underscore file description comma. We are listening 10 times. Like, let it loop for 10 times, which is fast. So we say if this is less than 0, okay, that means we encounter error, and we use our file printf. Okay, we use our file printf open bracket stderr comma double quotes, and our error here is coming from listening space error number %d arrow sign and %s \n double quotes error number comma and string error open bracket. I will pass in the error number close semicolon, then we return. We are not closing any file description here, so we return 1, and we close this error string. Okay, this string error we have been using, we have not give the actual header files where we can access it, which is in the hash include. So include this, guys, string.h. that's the header file to get access to that string error. Okay, then if everything works fine, we just like to print. We'll just use the printf function to say listening for connection. You see, for connectivity. See, for listen for connectivity. Now listen for connection is okay, not too much drama, please. So listening for connection, we say \n double quotes, and that is it. So this is what will be print out. Then while we listening for connection, I'll put a comment here to indicate the next function, which is accept connection. Accept connection. So this function allows us to accept connection. So we use if again, open bracket, pass in the client. Now we need to pass in the client. We'll pass in the client underscore fd file description, because that is what allows us to connect to the client from here. That means we are accepting connection from the client now. Okay, so we say now the function is accept open bracket. We pass in the server underscore fd open bracket struct space sock addr pointer. We are behaving as if we are casting it to the client underscore addr comma, and we are passing the address of the client underscore an, the client length. Okay, and I close this. I close again, and I will say if this is less than 0, I close open bracket. Make this a little bit smaller. Oh goodness, yeah, a little bit smaller. And I hope you guys can see that clear. Okay, so if you can't see it, just zoom it if you can't see that clear. do printf. Is that printf? F printf, yeah. So we pass in the stderr, or I can zoom it, no worries. Let me zoom it a little. Even though it begins at this next line, just know that it begins, but just know that it begins from this next line. Okay, this if statement, you can see that I go to the way end and it begins from the next line, so just have in mind. Okay, stderr open bracket, we see accept error number %d -- arrow sign. What does this %d mean? We are getting it /n, comma, pass in first the error number, comma, and we use the string error function to get the actual error number, and we close, semicolon, press enter. So if we encounter error, we are closing this time the client. Remember, we're closing it in the client file description. Okay, take off one, we're closing it in the client file descriptor, but that is where we return to. If you can see it here, that is where we return to the acceptance. So if there's error, we print the error and we'll close. So I'll just comment this, say close client underscore fd, and the next thing is to return. Since we indicate an error, we return 1 to the main to terminate the program, and we close this, and that is it. Okay, once we are done, the next thing is to say everything works fine. You want to print to the screen, okay, to say connection establish, connection established, and new line, and that is it. So when we establish the connection, then the next thing is we like to print the information of the port and IP of the client that is connected to us. So I would just like to add that, just a preference. I would like to print it out as well. So we'll do this. We say client IP we say %s, yeah, client IP we say %s, and /n, comma, and we use the inet underscore network to character, or is it character to network? No, it's network to character, yeah, because that is a character. So we pass in the client underscore addr dot syn underscore addr, sorry, that is not underscore addr, and that is it, and we close. And lastly, we also do a print again. Okay, client double quote, then we say client ports 1 2 3 arrow symbol, and we'll do this time it should be %d because this is port /n /n. We want it 2 times. Okay, and now we use the network to host socket. Okay, and we pass in the client underscore addr dot syn, which is to the struct underscore ports. Okay, and we close, and that is it. So once we are done with this, we now have everything printed. Then we need to enter a while loop where we can have access to it. So it's going to be a forever loop. So we'll pass in the true define micro. Then we close this. So inside this while loop where lies our communication. So first, what will happen now? Server will first wait for response from the client. Okay, let the client, because the client is the one connecting, so it should be the one sending message first. So server will dictate that you are connected. So server is waiting for your response. You know, like when you come to someone else, someone you have to knock. Okay, it's like you have to speak with the person because you are the one that comes to the person. So server first will read. So we say receiving. Okay, do I know how to spell receiving? That to spell receiving. Well, that's just a comment though. /asterisk. We say receiving from client. Okay, what are we receiving? Receiving message, receiving data. Call it data because everything is data from client. Asterisk /. So when we are receiving from the client, we would like to print. We would like to receive first with the receive system call. We pass in the client underscore fd file description. Where are we receiving it to the buffer of array, and we'll get the pass in the buff underscore size of array comma, I'll pass in 0, which means end of this file. Then once we are done with that, we use the print f to say from, we say from client. Okay, you say %s, that is a string. Okay, new line, I'll put comma and I'll pass in buff and we close. So with this we print the message from the client. Then the next thing we have to do another comment, say send. Now the server has to reply since the client has sent a message. Say server server response server response. That res oh sorry, I for insertion server. I forgot how to spell response. Server response back to client. Okay, so now server wants to send the response back to client. So what happens here now? We'll first do the printf. Okay, this printf we just say server column space double quotes and we close. So now we use the f get string open brackets, then we pass in the buff of the array, the buff underscore size, sorry, that's the wrong spelling, size, comma, and we say we are getting this from the standard input and we close that. So once we get the string is now being sorted, then we use the send system call to send to the client underscore fd yeah, we send to the client underscore fd, we pass in buff, pass in buff comma and the buff underscore size, which is the site, and comma 0 to indicate we have reached the end, and that is it. So if everything works fine, we should have this program running effective. Okay, so guys, what a huge one though. So let's compile this code and see if everything works as planned. Let me just comment here real quick. We say macros. We say macros. So that's just a simple comment that this is a macro. Hash, we close, we come out. I will use the GCC. You can use the CC, or you can use the Clang, any compiler you want inside this tree. But which is this? We use the GCC, which is the GNU compiler, the GNU C compiler. Then we pass in the server.c output to server, and we press enter, and our code compiles, no single error. Wow, that's nice. Then let's run this ./server, and I will just put my local host just for testing sake for now. Later I'll put VIP local host, and I'll put 8080, which is the port. Pass enter. See, listening for connection. Now it's waiting for the server to connect, but since we have not written the client, the server is waiting for the client to connect. Sorry. So since we have not written the client, it will remain like this until a client connects to it. Then we say connection established, and it will give us the detail that actually client connects. The port of the client we give from the client, and the address of the client, say, which is of the same of the server. Then it will give us what we call public port. Okay, a secured port that no one can know. Okay, no one can know. Even though you know this 8080, you can hack in, but that public port is the actual one. Okay, it will bring to it will add the system structure of the SOC address we assign it for us. Okay, so I'll press Ctrl D for now. So let's go write our client. Remember, the client is here, ls, see it, client.c. So we need to now write the client.c. Wow, this stuff though. So let's write, you say this one will be called the C standard standard libraries. That's a comment, just the way we did in the server aspect. All right, so hash include stdio.h. all right, hash include again string.h. okay, hash include again stdlib.h. okay, hash include again unsistd.h. all right, so the assembly, we say assembly system course, hash include then sys/sockets.h. We also include inet/in.h, and we also include the appar/inet.h, and lastly we include the file control.h. all right, so that is it. We pass in macros, comment this, that this is a macros. So hash define protocol. The protocol is 0, hash define true, and 1, this is 1, and hash define buff underscore size, this is 10,000. remember, the buff is incorrect spelling. Okay, so int main open brackets so that this thing can look okay for you guys. Okay, int argument of count, comma, and character of pointer of argument of vector of r. We close, we open, return 0. Okay, and it is it. So let's start writing our code. So oh man, it's already paining me in typing. My keyboard is kind of like strong. Strong keyboard, like it's hard to press. Just have to change it though. You can hear the sounds. Get a lighter one. Okay, first of all, we'll create our file description of client underscore fd, comma, port, and create our character of pointer of IP, comma, and buff array of buff underscore size. A quick explanation why micro. Every time you are declaring a micro in C, let it be a uppercase character. That is how it's supposed to be, okay? Because this micro are also seen as constant. If you are declaring a normal constant as a global, you just do it this way. Just for example, we say integer const something like this x. You say equals to, the x must not be a small letter, it must be a big letter because it's a constant. Okay, good. But just take note on that. So the next thing here is our struct of sock addr underscore in. We call it server underscore addr. Why we put this server? Because so that it allows us to connect to that server. Okay, so we need that particular name of that server. If we change this name, it will not work. And after that, we need to pass in to IP the argument of vector of 1, and we close that. Port equals to character to integer function, and pass in the argument of vector 2, and we close, and that is it. Now before we pass in, we are supposed to check for errors. Yeah, we're supposed to check for errors here. So if arguments of count is greater than 4, that means we encounter error. So we do print error, and we say too many arguments pass. Okay, and that is it. We return to the main one, and with that we encounter error. But if there is no error, then we set all this variable here. Okay, all right, now we are done with that. Our next thing is to create the socket. We use our if statement. If you are writing an if statement, please don't always put your bracket like near the if. No, always give space, because the if is a keyword. Most people call it reserve word, but it's a keyword in C language. So we are passing the client underscore fd, because this is a client. Say is equals to the sock function. We pass in the af underscore inet family. Pass in the sock underscore steam, comma, and we pass in protocol, and we close. We say if this is equals to minus 1 minus 1, then we open bracket and we use the file printf to get our error. So our errors will be sent to standard error, comma, then the string of the error we are getting is socket error number, also %d arrow sign %x \n, and we pass the error number, comma, and the string error, and we'll pass inside it the error number. We close semicolon. That is not semicolon. Then if everything do not work well, we encounter this error, we use a close to close the client underscore fd. I said I'll always be commenting this one, say, which means close client underscore fd. Then at the end we'll return 1, and we close this, and we close this. Else, if everything works fine, then I'll put a comment here, say set socket address. Now we say server. Now we are binding it again. Now we are setting the socket address, like connecting our wallet, just as I explained, using house wallet. We need to tighten those house wallets on the wall and begin to unpack the component and making it work. So with the server underscore addr dot send, okay, we are telling it that we want to connect to the family, which is the af underscore inet. They have another one called af, no, is there another one called ap, something like that, but we are using af. Okay, we got that. Server underscore addr dot, server wrong, spell that wrong, server underscore addr dot syn underscore port port equals to host to network socket. I will pass in our port we got from the terminal. We use our inet underscore port to network, pass in the af underscore inet in uppercase, and we'll pass our IP, comma, and the address of the server underscore addr dot syn underscore addr, and that is it, semicolon. Okay, if everything works fair, then we close this. See, typing error here is supposed to be arrow here. Yeah. Then at the end here we close the bracket. Then the next thing is we say connect to server. Now I want to connect to server, which we will print on the screen connected successfully. So we use the if statement again, open bracket, with the f return to file descriptor. No, so we just connect, open bracket, to the pass in the client underscore fd. Okay, pass in the client underscore fd, open brackets, struct sock addr pointer, and we close that. Pass the address of server underscore addr comma, and we get the size of server underscore addr, and we close and close and say if this is less than 0, we close, open bracket, press enter. Now we use our fprintf to get the error to the stderr comma and our string. So connect error number %d %s \n, and we'll pass in the error number comma, pass in the string error, open bracket, error number, we close, semicolon, and we return 1. That will indicate an error, and we close this. Now we have connected. So we like to print to the screen. We like to use the printf to print to the screen. Say connection establish, but before we print, let's print new line \n connection established, and we print \n two new line, and we close. Okay, so we got our connection established, and it's time to read now to communicate with the server. Okay, so to communicate with the server now, since the server afraid now, since the client is communicating, so the client should be the one sending. So the client, first of all, we are printing first, we say client at the client side column, and we close, press enter. We'll do f get string to where buff comma the buff underscore size comma, and we're getting it from the stdin, and we close. Now that which we get, we want to send it. Want to send it to what? The server. Want to send it to who? Do we need to have a server file description? This should be sent to the server. The connect has to return to the server. We're going to face small problem. Okay. Comma, say server underscore fd comma, then let's do it this way, is equals to server. If it did not work, we'll just come back and remove it. Just open bracket. We go to the end and the end here. Okay, I made this a little bit smaller so that it fits. Okay, so we go down, and that is it. So we are sending to the server. to the server underscore fd comma buff comma buff underscore size comma 0. We close semicolon. So let me comment this real quick. We say /@service. We say send data to server. Send data to server */ then at the bottom, since we send, we need to receive from back receive we spelled receive if receive from server. So this receive from server now will be, we do the receive function, open brackets, server underscore fd comma buff comma buff underscore size comma 0, close semicolon. Then we print f, we say from server column %s \n comma and we'll pass m buff and we close semicolon. Okay guys, I think we are almost done. Alright, so the next thing is to check if we have any errors to run this code. If we have any errors, we just come and fix it. Okay, so we'll go compile this. I'll use the gcc again, say client.c-o, and we call this client. Press my enter key. Wow, 1000 both size. From macros 10,000, expanded from macros. Okay, both size comma on expected identifier. Okay, what almost 6 errors we are getting here. The error number %d. Oh, we're not supposed to get error there, dude. Error number. Use of undefined identifier, error number. Use of undefined identifier, error number. Almost all the error from the error number. Okay, let's go back and see. Let's go back and see where the error is coming from. Standard error socket %d. Oh yeah, %x. This one works now. We check the other error numbers. Oh yeah, string error number. That's okay. So let's compile now and see. Okay. Error number. We're not supposed to have error on that. Use of undeclared identifier, error number. Okay. Okay, let me cut um CAT um CAT. No, I'll cut the server dot c. Server dot c. I want to see what we did, the size we give to the buffer size. Sorry. Okay, it's 10,000. Then why are we getting error? Then let us go back to the code. Control P. Yeah. Control J, enter. Then we go up to the hash define buff size. All the places we use buff size, where are they? Okay, just here. Oh, I've seen that error. Yeah. I for insertion key, I'm supposed to put comma. I went and put dot, so here should be comma, and that error is fixed. So the next thing is to see the reason why we are getting the error number is not well working. There are just two error numbers here. String error. Oh, did I include the error number .h? Wow. Oh yeah. Sorry guys. So those are things we normally face. Hash. Yeah. Hash include. Okay, let's include hash include err dot ish. Oh, ish, and press enter. So let's go and escape shift column WQ. Press our enter key. Control L to clear the screen, and we compile again. So I'll just bring what we have typed back by pressing Control P, and now we compile by pressing enter. Okay, now receive. We have error in the receive, so we need to put dots, which is supposed to be comma. So we press Control P, shift Control P, so we enter, and we scroll down. We scroll down. Our code. You can see where we are doing our mistakes here. So I for insertion key, remove, and we add the comma. Escape, shift column WQ, enter, and Control P, and we'll compile this time, and everything works fine. All right, so ls guys, now if we press enter, we have the client and server. Okay, it's time to start the TMOS so that we can run our application. So we say TMOS, and we'll press enter. TMOS start, and we do Control B and shift %. We split the screen, so Control B and semicolon. So here we start the server by doing ./server, and I will give you the IP. I'll give you the IP I'll give you the IP 1.1.2.7. we say dot 0, that is not dot, that is comma, dot 0.0.1. now I'll give you the port 8088. So if we start the server now, if we press enter, now server is waiting to listen. Now let's start our client. We say Control B and I press my semicolon. Now I'm in the, so I will Control B semicolon, Control B semicolon. Okay, I'm in the other side of the terminal. That do dot / client, then I'll pass the same IP. Okay, 127.0.0.1. I'll put the same port 8080. Now they are connected. So if I press enter, you can see the server response, connection established, client IP 127.0.0.1, and the public port, which is 14418512. now we see we have the client. So client is ready to communicate to the server. So we write say hi and we press enter. Okay, it's receiving from server hi, which means everything is not working proper. So we have to go and fix this, okay, real quick. So let's go back to our code. Okay, let's go back to our code. So I will do Control C, then I'll type the exit, type the exit and press enter. Type Control C also and press Control L to clear the screen. The TMOS is still on, so I will leave the TMOS. So what I have to do is to bring up, say, vim client.c and press my enter key. So in the send and receive here, we should just pass in the client. We should pass in the client here. Client underscore FD. Okay, and send. We are receiving from, no, we should be receiving from the server here. We are sending to the server. We get from the input and send to the server. Here we receive from the, okay, let's put client. We say client underscore FD, and we go up here also. We say client underscore FD, escape shift column WQ. I will press our enter key and we compile again. Control P. What are we compiling? The client is what we are compiling. So I'm just looking for, oh sorry, I couldn't see that. So we'll type gcc space client dot c minus o client, and I'll press my enter key. That's compiled. So I'll do Control B Shift percent to split the screen. Control B column, sorry, Control B column, Control L to clear the screen here, Control L to clear the screen, and I will start up the server again. /server 127 127.0.0.0.1, and I fix in the port 8080. Press my enter key. Server started. Control B, semicolon, then we start the client also. Let's see if we can have a communication. Okay, and 127.0.0.1 8080 connection established. So we say hi. Let's see if server will receive. Okay, now see, server receive from client hi. Then we can send to the server, to the client back and say I'm fine. Say I'm fine, and you. So we press enter key. You see, from server, I'm fine, and you. So you see, they can communicate very, very well and very, very proper. But there's something that is missing here. I would like the code, the respond and receive to be to let it have space so that the communication can look neat and clean. Okay, so let us just reply the server back first. Okay, let us control B, and I will say same here. Press my enter key, and server receive from client, same here. So the app is communicating, but the response does not look after the client send, everything is just in the same line. So let us make it have space so that it look more beautiful. So I'll do Control C. I'll do exit. I also do Control C. I also do exit. Yeah, okay, just come out of the TMOS. Then we do vim server.c. Then we'll go to the bottom in our while loop. We go to the bottom here, say after we receive from client. Okay, after we receive from client, I for insertion key. So we like to print new line, so I can use the put sha. Can use the put sha function. So open bracket, single quotes, /n, single quotes, close bracket, and semicolon. Remove that one, then we'll go and compile. Okay, so as we are receiving, we are putting a new line. Let's go and compile this. Escape, shift column, escape, shift column, WQ, press enter. Then we'll compile this. GCC server.c -o server, compile. Then we do the same. We'll go and do the same thing in client.c, and at the bottom I. Then in the receive is where we are going to put it. Then after server, receive from server, we'll also like to print. Auto has to use the put sha, open brackets, single quotes, / single quotes, /n, single quotes, /n, single quote, and we close this and we'll put our semicolon, and that's all. So shift column WQ, we press enter key, I'll press our enter key. So we compile again. GCC client dot c minus o client, and we compile and it works. Clear the screen and we type our TMOS again. Control B shift percent to divide the section of the terminal. Control B semicolon, then we start our server / server, then 127, which is a local host, .0.0.1, and I'll put the port 80 and I'll press my enter key. Server starts. Control B semicolon, then we start our client 127.0.0.1 80. Okay, move this 0, put space, move to the end and press enter. And now see connection established. We get our ports and our actual IP. So we say hi server. Oh, press enter. Okay, see receive from server. I see the space. I mean, now it looks okay. So we go to the client. Okay, and we say client. Say I'm fine client. I'm fine client. Press enter. See, from server we say we print I'm fine client. The server is organized well, but the client is like the space. Okay, I'm fine client from the server. So we go back to Control B and we say we find, say how is your Christmas holiday. Okay, how was your Christmas? Not how is. So sorry, I can't press something on my keyboard. So say how was your Christmas? How was your Christmas holiday? Press enter. Okay, the Christmas holiday did not send back to the the server do not receive the how was your Christmas holiday. Okay, let's go and fix that real quick. So Control C, Vim, no, exit first. Let us exit out of this terminal session so I will have full screen. And Control C, exit, and we'll go back to the Vim client .c. Okay, all right. So first of all, we'll put a new line here first. I for insertion key. I will say printf, open brackets, double quotes, \n, printf, open brackets, double quotes, \n, double quote, close bracket, semicolon. Okay, All right, so let's go run. Shift column WQ and we'll compile GCC client dot C -0 client, and that compiles. And what we do now is type our TMOS and we Control B Shift % to split, Control B semicolon, we start the server, and this time everything will run perfect. 127.0.0.180 and listening, Control B semicolon /client 127.0.0.1 paste 80, press enter, connection established. So see what's up, server. Okay, send, Control B, and we go to clients. Hi nigga, say hi nigga, and we'll press enter, server reply. So you see everything is working perfect as we planned. Okay, so guys, this is all about the server and client communication application in C programming language. Kind of a little bit tough though, but I hope you guys enjoy it, and please make sure to give me a like and subscribe to my YouTube channel, okay, to this channel please. Okay, if you're following me on TikTok, please make sure you also follow me, share this video to your friends and to your loved ones. All right, so see you guys on my next video. Happy learning and see you guys. Bye.